Now in this question we have a different problem. It's fairly plain that the x's won't disappear by adding or subtracting because the numbers don't match, and the same can be said of the y values, the y terms. But if we try the previous trick of multiplying this by something so that this becomes a 3 such that they can cancel, there is no easy whole number that will multiply 2 to make 3. Similarly, with the same problem with this 3 and this 4. So we have to take an extra step again, and we need to multiply both equations by something appropriate, always bearing in mind what the aim of this is. We want to get rid of either the x's or the y's. Now we have lots of choices. We could multiply this by 3 and this by 2. They would both become 6x. We could subtract, maybe we'd have to add, we'd have to check that later on, but they would both be 6, and we could do a subtraction or addition. Similarly, we could multiply this by 4 and this by 3, turning them both into 12. But there are other choices. We could multiply both of these by 6 and both of these by 4. And we therefore have to try to find the most elegant solution, the one that involves the smallest numbers to keep things easy, and preferably avoiding negatives if we can. It comes with experience, but the best choice here is to multiply by 3 and by 2. Now, let's be clear. You can only work that out if you understand what the point of it is. Multiply the first equation by 3, we've got 6x minus 9y equals minus 6. That's going to be equation 3. And equation 2 being multiplied by 2, we've got 6x minus 8y equals minus 2. And that's now going to be equation 4. Okay, so we've arranged the equations such that if we make the right choice, then either x or y will be eliminated. I think by now you should be fairly happy that it's the x values that are going to get eliminated. We try a subtraction, and sure enough, 6x, take away 6x, does make 0. That's all good. The problem comes with all of these negatives. The potential for going wrong is huge. So you've got to be very careful. And again, if you don't write these negatives in such that you can't see them, you're just imagining them, you're far more likely to go wrong. 0. Negative 9y plus 8y makes negative y. Negative 6 plus 2 makes negative 4. Now, whether you want to multiply both sides by minus 1 or divide both sides by minus 1 doesn't really matter too much. In either case, you will discover that y equals 4. Now we're back into the routine that we've been practicing for some time. Substitute y equals 4 into the easiest equation. Both of these have lots of negatives. The numbers there are slightly smaller. I'm going to go for equation 1. Doesn't matter too much. 2x take 3y equals minus 2. 2x minus 3 times 4 equals minus 2. 2x minus 12 equals minus 2. Add 12 to each side. 2x equals 10. And divide through by 2. X equals 5. So as we've seen a few times before now, these lines that we started with will intersect at x equals 5 and y equals 4. Just check that. In equation 2 said 3x minus 4y equals minus 1. Let's see if it does. 3 times 5 minus 4 times 4, 15 minus 16 makes minus 1. We've found the intersection at 5, 4.